simplifying rational expressions. At the end of this lesson, you should be able to answer, how do I use factoring to simplify rational expressions? And also, what values must be excluded from the domain? So on the screen here I have a little image that says, friends don't let friends divide by zero. Dividing by zero is the one value in mathematics that is undefined. There are different proofs you can consider as to why this works, but you cannot divide by zero. If you tried on your calculator, you would get an error message. Zero is okay in the numerator, but not okay in the denominator. So if this is the truth, you must restrict any value that would cause a denominator to be equal to zero. For instance, on the screen it says, what values must you exclude from the domain? So the only thing you need to consider is look at the bottom and consider what values would cause the bottom to equal zero. What values? Well, I'm going to actually say can't equal zero because I don't want it to be zero. So I'm going to divide both sides by 10 to isolate, and I get x cannot be zero. So if it were, it would cause a division by zero error. So this statement makes sense as long as x is equal to zero is not in the domain. In the second one, I look at the bottom, which is x plus 4, and I say the denominator here can't equal 0. So I would subtract 4 from each side. So this is fine as long as the domain is not equal to negative 4. In the third one, denominator is a little more complicated, but again, I say 2x minus 7 cannot be 0, and I solve. So 2x cannot be 7, and I divide by 2, which would be x cannot be 7 halves. If I would plug in 7 halves right here, I would have 0 in the denominator. Number 4, to consider this one, I'm going to factor first, which would be the difference is 2 squares pattern, because I have a perfect square minus a perfect square, and I get x plus 2 times x minus 2. So it's easier to look at what would cause a division by zero error in this case. So I take each of these, because if either of them is equal to 0, the whole bottom is 0. So I say both cannot be, and this would be x cannot be negative 2, or x cannot be positive 2. And if you would substitute back in the denominator, you would both get a division by zero error in both cases. Now let's consider how to actually simplify rational expressions. And when I say rational expressions, it's simply a fractional value where I'm going to have some sort of polynomial in both the top and the bottom. So what you're going to do is factor the numerator and denominator, because the only values in math that you can reduce in the top and the bottom would be things that are multiplied together. And if you think about back in a very early math class, you knew that 4 over 8 would reduce to 1 over 2. Now, if you had 4 plus 1 over 8, you could never reduce the 4 and the 8 and make that a 1 and a 2, because that would result in 1 plus 1 would be 2 over 2, which is 1. There's no way that this is 1. This should be 4 plus 1 would be 5 over 8, it's 5/8. So you get two different values, and this gave us a wrong answer because we were crossing out things that were connected with addition. You can only cancel things that are connected with multiplication, meaning factors. All right, so what we're going to do is factor. We're going to cross out any common factors, and then we're going to state any values that would cause a division by zero error. And once again, I've tried to emphasize never cross out terms, only factors. Terms are things that are added and subtracted. So let's illustrate this with some examples. R divided by 2r. Well, I look at this, 2 times r, so it's all held by multiplication. So I'm going to start by canceling my r's. R divided by r is 1, so this would result in 1 over 2. But I have to consider what would cause a division by zero error. So if I take the bottom, I say 2r can be equal to 0, and divide both sides by 2, so r cannot be 0. So my answer here is that it simplifies to 1/2, but I have to say as long as r is not equal to 0. Now, in number 5, my factors that are the same are 5 and 5, so they reduce to 1. I cannot cross out the x and the x plus 2 because there's a plus sign there, so this would be x over x plus 2. Now, I look at just the bottom. Well, the first factor, 5, is never going to be 0, so that doesn't cause any issues. But where there's a variable, I have to be careful. So x plus 2 cannot be 0, I subtract 2, I get x cannot be negative 2. So my answer here is, this all makes sense. The It reduces to x over x plus 2 as long as x does not equal negative 2. All right, now, number 6. What would be incorrect is some students start crossing out x. They start reducing like 4 and 12. That is wrong. You cannot do that. You must factor. So I go through my factoring methods. My first factoring method is factor out the GCF. Always start there. So out of the top, I get 4 times the quantity of x plus 4. On the bottom, I get 3 times the quantity of x plus 4. Now, you should really get in the habit of stating your factors before you cross things out. So the only thing that's going to cause an issue is this x plus 4. So immediately I'm going to say my restriction. This all makes sense as long as x does not equal negative 4. That is what's going to cause the division by 0 error. And now I'm going to go and cross things out. So x plus 4 and x plus 4 are identical. So this reduces to 4/3 as long as x does not equal negative 4. That would be my restriction. All right, number 7 is already in factored form. So my restrictions here, I'm going to look and state my restrictions. There's going to be 2 in the bottom. This first one is going to give me x cannot equal 7, positive 7. The second one, I'm going to actually write this one out for you to see. 2x plus 1 cannot be 0, so I'd subtract 1. So 2x cannot equal negative 1. Divide by 2, I get x cannot equal negative 1/2. So here's my 2 restrictions. Now, what does it simplify to? Well, the x minus 7 divided by x minus 7 would be 1. So in the top, I have 4 times 1 is 4 over 2x plus 1 is what it reduces to as a fraction. And it has 2 restrictions. Let's take a look at number 8. Number 8 is not completely factored. I look at the denominator and I have a binomial. There's no GCF I can pull out, so I look for my difference of 2 squares. I do have a perfect square minus a perfect square, so this is going to factor into 2 binomials. I take the square root. Pattern says one's a plus, the other is a minus. Square root of 4 is 2 and 2. So I already know I'm going to have 2 restrictions because there's 2 factors with variables in the denominator. So my 2 restrictions are going to be v cannot be negative 2 or positive 2. What does this reduce to? Well, v plus 2 divided by v plus 2 is 1. So I get 1 over v minus 2 for a simplified answer with 2 restrictions from the domain. In number 9, I have a trinomial in the bottom. So I'm going to see what this factors into. I'm looking for, let's see, h squared comes from h times h. The fact that this is a minus tells me that one is a plus and the other is a minus. The signs are different. So I need factors of negative 12. And they're going to need to add to negative 1. So I'm thinking either negative 4 times 3 or positive 4 times negative 3. And it's going to be this combination. So I'm going to put the 4 here and the 3 here. And you can quickly check that by foiling to make sure that you factored correctly. And I'm going to immediately state my restrictions so I don't forget about them. My 2 restrictions would be h cannot equal negative 3 or positive 4. As far as what it simplifies to, it would be 1 over h minus 4. So there's the simplified answer with 2 restrictions. Okay, just stepping it up a little bit with the amount of factoring you have to do in these last 2 examples here. Alright, so in the top I see the difference of 2 squares factors into m plus 8 times m minus 8. The bottom, m and m. This is a minus, tells me one's a plus, the other's a minus. And I need factors of 8. 1 and 8, 2 and 4. I'm going to try 1 and 8 because it needs to add to negative 7. So I'm going to put the 8 here and the 1 here because positive 1 plus negative 8 would equal negative 7. Now what cancels? Looks to me like the m minus 8 and the m minus 8 will cancel, resulting in m plus 8 over m plus 1. I believe there are 2 restrictions from the denominator. M cannot be negative 1, or the second one that I crossed out was m minus 8 cannot be 0, so I solve, add 8 to both sides, m cannot be positive 8. So 2 restrictions. Now, number 11. Okay, so I have two trinomials. Look for a GCF. There is not one on the top, so I'm just going to factor that into two binomials. The bottom looks like I can factor out a 2 first. It would give me g squared minus 8g minus 9. The top, g and g, one's going to be a plus, the other's a minus, factors of 45. I'm going to try 9 and 5. Be minus 9 and plus 5. Now, I believe I can factor the bottom further, so I'm just going to recopy the top and try to split up this trinomial. Again, one's going to be a plus and one's a minus. Factors of 9, 3 and 3, 8 and 1. I'm going to try 8 and 1. I'll go with minus, I'm sorry, not 8 and 1, 9 and 1. 9 right here, and a positive 1. That gives me negative 9 when I multiply, and it adds to negative 8. So let's look at what cancels. So I would have the g minus 9 times g minus 9 right there. They would reduce to 1 and 1, resulting in an answer of g plus 5 over 2 times the quantity of g plus 1. Now, you'll see some textbooks want you, because the directions are simplify, to redistribute what's in the bottom to make it 2g plus 2. Many other textbooks, and I'm fine if you leave the bottom in factored form. Now, we do have two restrictions because we had two factors with variables in the denominator. So what's in the box is my answer, but my two restrictions are this is true as long as g does not equal negative 1 or positive 9. Okay. Final question here is an error analysis question. So take a look at what's been done and see if you can identify where the error is. My trick with identifying things with errors is I just follow the reasoning through. So it looks like they canceled common factors and had 2 over x plus 2, and then they canceled the 2 and the 2. Hopefully this right here stands out to you as an incorrect step. And what is wrong is they canceled terms, not factors. So the answer should just be 2 over x plus 2. And it looks to me like the two restricted values are correct. Okay.